Hi, Mr. Richmond. This is your lesson summary for Unit 2.3, Modeling Linear Inequalities. In this section, we're going to continue working with the idea of solving. Instead of equation this time, it'll be inequalities. So in our first example here, we'll show you how to go through the steps to solve a linear inequality, which will be very similar to how we solved linear equations, only we'll have inequality signs, less than, greater than. And then we'll talk about how to display that answer. Because our answers can be more than one number now, we're dealing with things like x greater than 3. We'll need to show that a little differently, so I'll talk about how to represent that on a number line. We're going to deal with a couple of the rare rules that exist with inequalities that are a little different than equations. And then we're going to take a look at a word problem, and we're going to talk about how to represent that problem with an inequality, look at it on a coordinate plane, and kind of see where the different solutions lie. So let's start right away with solving inequality. Now this is mainly review. I know some people this will be a little stronger on this skill, but let's go right into it. So if I want to solve a linear inequality, something like 25 plus 9x is greater than or equal to 70, I'm going to solve it the same way I would an equation, which is trying to isolate the variable. I'm trying to get 9x by itself. Before I can do anything with a 9x, I want to completely isolate the variable and its coefficient, which means this positive 25 I need to get rid of. To get rid of anything in an equation or an inequality, I have to keep it balanced. Whatever I do to one side, I have to do the other. And if you want to get rid of a particular operation or a particular number when solving, you have to do the opposite operation, the inverse operation. So since this is a positive 25, I need to do a negative 25, or minus 25 to this. Now, to keep it balanced, whatever I do to one side, I have to do the other. So this inequality sign acts as a balance point, just like it does in the equation as an equal sign. So since I did a minus 25 here on the left, I also have to do it on the right. Now I can simplify down. I end up with a 9x greater than or equal to, same inequality sign. 70 minus 25 would be 40, 45, 55, 65, 70. And now I've simplified down a little further. At the point when you have just your variable on one side, you're now able to try to break up that coefficient and completely isolate it. Again, opposite operations. 9 times x, do the opposite of multiplying, which is dividing. So I'm going to divide both sides by 9. Bring it down. 9's cross out. Bring down my inequality sign. X is greater than or equal to 45 divided by 9, which is 5. And that gives me my final answer for the simplified inequality. I've isolated it. My answer for x is all numbers greater than or equal to 5, which means 5 should work, 6 should work, 7, 7.5, anything beyond that. Plug 5 in and check. 5 times 9 is 45. 45 plus 25 is 70. 70 is greater than or equal to 70. So I kind of feel good about that. Now I can also display this answer, and we'll typically have to display this answer on a number line as well. So I can put a few numbers. You don't really have to put all of them. Most teachers are okay with you putting 5 and then numbers near 5, like 6 or 4 on each side and just shading. I'll put more of them for this example though. And it's x greater than or equal to 5. Now if you think back to pre-algebra, you've done greater than or equal to. It's kind of like the alligator will eat the x because he's more than 5, he's greater than 5. Some teachers also teach that if the variable's on the left and you write it in this way, you always shade towards the direction the arrow is pointing. It's pointing right. I still think it's best just to think logically. This is saying numbers greater than 5. Well, what's the first number greater than 5? Well, 6. So I'm going to be shading towards the 6. Because it can also include 5, I use a closed dot on 5. Okay? If it was a less than symbol, or a greater than symbol like you see here in example B, I'd use an open sign. When we get there, I'll show you what I mean. From there now, I'll shade right or darken in the graph to the right, and because it'll go on forever, I can darken in the arrow as well. So that's how I can display it on a number line as well as an algebraic inequality. Okay, let's take a look at B. Now here, again, I have an inequality. There's several ways you can go about this. Some teachers might want you to distribute first. Others might want you to divide out the -2. It's whatever you think. I'm going to always, for this simplicity of this class, say simplify the left side first, combine like terms first, and kind of go that route. So for this, just as practice, I'm going to go ahead and distribute. A -2 times an x is a -2x. -2 times a -5 is a positive 10. And I've at least simplified the left side. Now if there's any like terms, I'd combine them, any x's to combine with other x's. Since there's not, I'm ready to solve. Again, I want to isolate this first, okay? Get rid of the plus 10. I do that by subtracting 10 to both sides. 16 minus 10 is 6. And I have negative 2x is greater than 6. At this point now I'm free again to try to isolate that variable, to separate its coefficient from it. So I have to do the opposite of this. Now, it's not a minus 2x, it's a negative 2 times x. Whenever anything's touching in math, it's multiplication. So I need to do the opposite of multiplying, which is dividing. I do that, the negative 2's cross out, 6 divided by negative 2 is negative 3. Now you notice I didn't write the inequality sign yet. It's because I want to examine something here. Let's just say that this inequality sign stayed the same, that it was greater than negative 3. My answer would be numbers greater than negative 3. So what's the first number greater than negative 3? Well, negative 2 would be the next whole one, or integer number that would work. Let's check that before we go further. Negative 2 minus 5 is negative 7. Negative 7 times a negative 2 is a positive 14. Now, is a positive 14 greater than 16? Well, no, it's not. So, something wrong here, fundamentally, with keeping this inequality sign the same. And even if I plug other numbers greater than negative 3, you're going to see that it's not really ever going to work. Well, why is that? Well, so let's just take a look at something. Let's change this inequality sign the other way and see what happens. Now I have numbers less than negative 3. Well, a number less than negative 3 would actually be negative 4, negative 5, etc. Plug a negative 4 in. Negative 4 minus 9 is negative 9. Negative 9 times negative 2 is a positive 18. 18 is greater than 16. So why does that work now? Why did that need to switch? Well, we're in this weird thing where we have a negative number times a negative number. And in math, when we get this negative number times a negative number, it becomes positive. Well, I want my number to be greater than 16. And so we kind of just get this weird dynamic here where you actually want to use really large negative numbers like negative 8, negative 9, negative 10 because they're going to turn positive anyways. And so anytime in math and solving inequalities where you end up multiplying or dividing by a negative in a step, multiplying or dividing by a negative, you have to flip your inequality sign. Okay, make a note of that. So the actual answer here is going to become x less than negative 3. And I'll now want to graph that on a number line. This time though, it does not include negative 3. It's less than only, it doesn't have the less than or equal to. So I'm going to use an open dot on negative 3 because that in math, in this representation means up as close to that number as possible without actually including it. So it'd be negative, if I was coming up this way, it'd be negative 2.999999, but not actually ever 3. I'm less than 3 though, so I'm going this way. Shading to the left, because that's where numbers less than negative 3 are. Okay. Application-wise, more of a real-world problem with this is, where would I use this and how could I express that? Well, in this situation it says John has $30 in his gift fund. If he would like to have at least $60 for gifts in 5 weeks, how much should he save per week? Well, there's a relationship here, okay? There's an input-output type of relationship. I have time, okay? He has so many weeks to save money, okay? I have the amount of money that he actually has in his account. So he's starting with some, and then every week he's getting more. I don't know how much he's saving per week, so that will need to be a variable. I think I can make that x, okay? And then my other variable is the amount in his account, y, or my output. So for writing a function, f of x is my output, and money he saves per week as my input. I should go ahead and write that. My independent variable will be money saved per week. And my dependent variable will be the money in his gift fund. Because the money in his gift fund depends on the money he saves per week. I'm going to try to go ahead and write a function for this now. So the money in his gift fund is equal to $30 no matter what, because he has that to start. And then he saves so much money, I don't know how much, per week for 5 weeks. So I can write that as 5x, because if he saves $10 a week, then it'd be 10 times 5. $20 a week, 20 times 5. Okay? So I now have a function that I could use to answer this question. But I could also graph this and get a visual representation, and that's what I want to do here, because I want you to start to see how this would work in the guise of an inequality. So I'm going to set up my axes. This will be money saved per week. This will be his money in his gift fund. If he saved $1 per week, then he'd have saved $5 that time. And with the original 30 he was in there, we'll put him at 35. Okay? He saved $2 per week, that'd be 10. 5 times 2 is 10. Plus the original 30, we'll put him at $40 per week. Okay? And I start to get the general trend of this line. Now I can continue plotting the points. Because I know the slope now is 5, it's really just continuing to go up by 5 each time. But since I know that now, I can continue that trend of that line. And so now I can see visually how much money he has at the end of this 5 weeks, depending on the amount he saves. Obviously, the more he's putting in per week, the more he's ending up with. Okay? Now, for this situation, I want him to have at least $60 for gifts. And we learned in the last section that I could graph the line y equals 60, output equals 60, which is always going to end up being a horizontal line in that situation, and kind of see where they intersect to get an idea of when that would happen. Okay? And you can see here now, anything below this, any dollar amounts below 60, he would not be saving enough per week to reach his goal. It's not until these intersect here that I know exactly where it works. So I want him to have at least this much. So anything beyond, above 60 is fine. And so really, I'm looking at this zone here. From here on, that's favorable for me in this situation. Okay, and you'll do that some in the example where you'll graph a function, a linear function, and then an output function, horizontal line, find where they cross and figure out what they need. Sometimes it's less than, so you'll circle the part that's underneath your horizontal line or above it. In this case it was at least that amount, so anything above was good, so I circled the amount above it. Now I kind of want to check and make sure that this is actually correct. I'm on a whiteboard, my skill's not real good. I want to see exactly where this intersection point is so I can answer it a little better. How do I do that? I take my function and I set it equal to the output that I want. I want the output here to at least be 60. So I'm going to change this now into an actual inequality. So the function was f of x equals 30 plus 5x. And if you ever want to get an answer, or sorry, yeah, f of x equals 30 plus 5x. If you ever want to get an actual answer for an inequality, then I have to turn it into that. Well, I want the output to be 60, and I want the actual amount he saves to be greater than or equal to 60. I want the function itself to be greater than or equal to 60. So I rewrite it now as an inequality. And now I can just go back to what we did here originally and solve it algebraically and get an exact answer, which is nice when you don't have a real clean, crisp graph. Again, follow my steps, subtract 30 to both sides. I get 30 is less than or equal to 5x. Divide both sides by 5. Okay, and I get x is greater than or equal to 6. If you have trouble reading it this way and you want to rewrite it to put the variable on the left-hand side, which a lot of students do, just look at where the alligator is eating. The alligator is eating the x. So as long as you rewrite it and you keep that alligator eating the x, you're going to be all right. So the answer that I have here is 6. X is greater than or equal to 6, which means to answer this original situation exactly, algebraically, it's going to have to be $6 or more per week that he saves. It has to be x is greater than or equal to 6. And my graph's obviously a little bit off because I'm on a whiteboard here, but roughly that is about where it crosses, and it matches that. Once I start moving beyond 6, I get to where I want to be. So to answer the question, how much should he save per week when he's saving for 5 weeks to get there? He needs to save at least, because he can always do more, he needs to save at least $6 per week to reach his goal, to have enough money in that account. So ultimately, that's what we're looking for you to do. Solve linear inequalities. Take a situation like we've done in other sections this year. Determine independent, dependent variables, write functions for it, graph functions, but then be able to look at a graph of a function and understand what part of it we need in terms of the inequality, and then use algebra to check that and secure that and feel good about that answer and have a nice exact solution. All right.